Hello, 2Ds. Welcome to the last unit of your math class. We will be continuing with quadratics for your last unit. So we're going to be using some of the ideas from factoring and expanding. But we're also going to be looking more closely at the graphs and how the graphs move around based on what other numbers are in the equation. So today, we're going to take a look at some special trinomials. In the last unit, we were looking at trinomials um, that have the form ax squared plus bx plus c, and you may have noticed some of them had special characteristics, but I wanted to go over the two of the special ones that you're going to see often in the rest of this unit and also as you go into your classes next time. So it's really important to be able to recognize these um, special trinomials because it makes it really easy to factor them and identify them if you can see it right away. So our learning goal today then is to be able to identify and factor perfect square and difference of square trinomials. So we're going to start with perfect square trinomials. So what in the world is a perfect square trinomial? Well, it really goes to what binomials we are multiplying. So if you take a binomial and multiply it by itself, you end up with a perfect square trinomial. So let's do an example. So let's say you have x plus 2 and you multiply it by itself. So another x plus 2. So let's multiply these out. So x plus 2 times x plus 2 gives us x squared plus 2x plus 2x gives us a total of 4x's, and 2 times 2 is 4. So x plus 2 times x plus 2 gives us x squared plus 4x plus 4. And this is what's called a perfect square trinomial. It is the trinomial that results from multiplying a binomial by itself. So squaring a binomial. So that's why it's called a perfect square, because it's a square of a binomial. So let's look at how to recognize these. Well, how do you recognize a perfect square trinomial? Well, they have the form, the number in front of x squared is a perfect square number, and the number at the end is also a perfect square number. And then the number in the middle is 2 times what a would be and what b would be. And don't I know this looks a little weird right now. We're going to do some examples so you'll get used to what they look like. They are expressed in the square binomial form like this. So a number times x plus b, different number, squared. So that means if we go back to the last slide, it was like this. This is 1x, so 1 would be a, and then b would be 2, right? So ax plus 2 times ax plus 2 or plus b gives you that result. Okay, now sometimes you need to use the minus sign, and we're going to do some examples with this. So first off, we're going to look at these three equations, which are perfect square trinomials. So the clue to figure out whether the first clue, I should say, is to figure out if this is a perfect square trinomial. You'll notice that the first term is a perfect square and the last term is a perfect square. So yeah, this could be x times x. This could be 5 times 5. But we also need to make sure that this term works out. And we're going to need to do that with all three of these. Because look, all of these, the first terms are all perfect squares. Because 16 is a perfect square of 4. 4 is a perfect square of 2. 36 is a perfect square of 6. But we need to make sure that these numbers in the middle also work out. And the sign in front of them is going to be important. So let's take a look at the first one. So we have x squared plus 10x plus 25. Well, take a look. The first term x squared is the square of x. or 1x. Remember, sometimes we can have an a value in front of the x. Well, if there's not a number there, it's 1. So 1x. The third term is the square of plus 5 or negative 5. And that's really important to remember when we're dealing with squares. That remember, you can take the positive version, but you can also take the negative version. And the hint to which one to take here is the sign in front of b, in front of our middle term, I should say. So because this is positive, we're going to take positive 5, because if you take negative 5, you would get a negative number here, and that's not going to work. So if we put these into our form, so remember our a is 1, our x is x, our b is 5. We took 5. Okay, so if we put those numbers into this form, so a squared is 1 squared, x squared is x squared. Then we put it into 2 times 1, which is our a, times 5, which is our b, plus b squared, 5. And I'm going to change this, since b is plus, I'm going to say since the middle term, because that's not b. Since the middle term is 0, we take plus 5, put these into that. Okay. Because that was a little bit of confusing because I was doing 2 b's there. So let's just go through this again. Okay. So now we're subbing in, this is our a and an x, and this, my son wants to get Pokemon Go. Not now. Okay, and our b, we took plus 5. So now every time you see an a, you put in 1. Every time you see a b, you put in 5, and then we do the calculation. So this is just to check to make sure it is a perfect square trinomial. Okay, so this gives us x squared plus 10x, because if you do 2 times 5 times 1, we get 10, and then 5 squared is 25. So yes, this is a perfect square trinomial. If we were to factor it, the nice thing here is you don't have to think too hard, because once you have your a value and your b number, you just plug them into your factored form. And then you can double check this by expanding this. So x plus 5 times x plus 5, well, x times x is x squared, x times 5 is 5x, 5x times, so 5 times x is another 5x, so you get 10 x's, and then 5 times 5 is 25. So if you see something like this where you realize, hey, this first number is a perfect square, this is also a perfect square. And if I take not the sum, the product of 2 times my number in front of my x here times the square root of this number, do I get this middle number? So if I go 1 times 2 times 5, I get 10. Okay, so let's try another one. So we've got 16x squared minus 48x plus 36. Now we notice here 16 is a perfect square and 36 is a perfect square. So let's see if this works. So the first term, 16x, is the square of 4x. And the third term, 36, that's the square of positive 6 or negative 6. Now, since, I'm going to change that again, since the middle number is negative, you're going to try out the negative 6. And then we're going to see if that works out, to see if this indeed is a perfect square trinomial. So our a is 4 and our b is negative 6. So every time you see an a, put in 4, and every time you see a b, put in negative 6. And this should work out. So 4 squared times x squared, plus 2 times 4 times negative 6x plus negative 6 squared. 4 squared is 16x squared. 2 times 4 is 8 times negative 6 is negative 48. And negative 6 squared is 36. So yes, this is a perfect square trinomial. Now, you don't need to do this to put it into factored form. This is just showing you how we know something is a perfect square trinomial. So if we put it in factored form, then you're going to take your first term that you found and your second term you found and put them in factored form. So it's going to be 4x plus 6 times 4x plus 6. Because remember, a perfect square trinomial is the binomial times itself. So these have to look exactly the same. And if you expand those out, you will get this back. And you can try that on your own if you'd like. Let's take a look at this one. We've got 4x squared minus 25x plus 36. Well, let's see. The first term is a perfect square and the last term is a perfect square. We just need to check to make sure that this works. So the first term is 4x squared, and I need to change this again since the middle number is 48. You can see the answer down there, but that's okay. Okay, so the first term, 4x squared, is the square of 2x, and the third term, 36, is the square of plus 6 or negative 6. Because the middle term is negative 25, we're going to take the negative version of 36, or sorry, the negative 6. So now we're going to put these into this form. So our a is 2 and our b is negative 6. So that gives us 2 squared x squared plus 2 times negative 6x plus negative 6 squared. Well, if we multiply these out, we get 4x squared minus 24x plus 36. Wait, that doesn't match. So that means this must not be a perfect square trinomial. So we're going to end it there because we can't put that in factored form because there's no two numbers that can multiply to give 36 and add to give negative 25. And we're going to go on in our next lesson to figure out how to actually factor these when there's not a 1 here. It's a different number. So don't worry about that right now. So that's how we look at perfect square trinomials. Remember, the first and last terms have to be perfect squares, but you need to make sure you're checking that middle term. Let's take a look at difference of squares. They look similar when we look at the factored form, but they give you a very different result. So anytime you take a binomial and multiply it to itself with the opposite sign, you end up with a difference of square trinomial. So let's say we multiply x plus 2 and we multiply it by itself with the opposite sign, so x minus 2. Well, let's see what we get. If we do x plus 2 times x minus 2, if we do our FOIL method, x times x is x squared, 2 times x is 2x, x times negative 2 is negative 2x, and 2 times negative 2 is negative 4. Well, check this out. If you have a positive 2x and a negative 2x, they cancel out, don't they? So we end up with x squared minus 4. So this will give us a hint as to what kind of trinomial we have. A difference of square trinomial are of the form a squared minus b squared. Okay, notice how there's nothing, so it's still a trinomial, but if we go back here, the term in the middle, the x term, just has a 0 on it. So they have the form something squared minus something else squared. And if we put them in factored form, That's going to be your first term minus your square root of your second term times your square root of the first term plus the square root of the second term. So let's take a look at some examples. Let's take a look at x squared minus 16. These are both perfect squares, right? If I square x, I get x squared. If I square 4, I get 16. So this quadratic can be restated as x squared minus 4 squared, right? Which is a difference of squares. You have two terms that are squares and you're taking a difference. So that's why it's called a difference of squares. So if we apply the formula on the last page, x squared minus 16 equals x squared minus 4 squared like we did here. And because remember on the last page, you just take the square root of the first term and put it in the first spot in each bracket. And then the second term, you take the square root. So the square root of 4 squared is 4. And you put it in the last spot in each bracket. But you need to have one with a positive sign and one with a negative sign. I like these a lot better than the perfect square trinomials. They're much more easy to recognize. If you have two numbers that are squares, perfect squares, and separated by a negative sign, there's a good chance it's going to be a difference of squares. So let's do another one. This one we have 4x squared minus 25. Well, take a look. This is a perfect square again. So the square root of 4x squared is 2x, and the square root of 25 is 5. So if we follow the steps we did before, so 4x squared minus 25 can be rewritten as 2x squared minus 5 squared. And now to write it in factored form, you're going to take this term and put it in the front of the bracket, of each bracket, and you're going to take this number and put it in the back of each bracket, and then you're going to have one with a negative sign and one with a positive sign. Let's do one more just for kicks. Ooh, x to the fourth. I'm just throwing this one at you. Just take it to the next level for you guys. You're 2Ds, so you can do this. Notice how x to the fourth, that would be x squared squared. This will not be on a quiz or a test because this is going above and beyond what you need to know, but I just wanted to throw it at you anyway. So this quadratic can be rewritten as x squared squared, and 1 squared gives you 1. So x squared squared minus 1 squared. So if we rewrite it like this, then in factored form, this is going to become the first term of each bracket, and this is going to be the last term in each bracket. And then make sure you have one negative sign and one positive sign. Okay, so that's the lesson. I have posted a special trinomials practice sheet. It's not going through as much as we did with the perfect square trinomials. It's just getting you to practice factoring them. And remember, this is all about finding perfect squares. If it's a perfect square trinomials, the signs in your factored form are both positive. If it's a difference of squares trinomial, you're going to have one positive and one negative. So I have posted this special trinomials practice sheet, and there are answers included so you can check your answers. Once you're done that, you can go on to the 5.1 quiz on Brightspace. So that's it for today. Next time, we'll be factoring trinomials a little bit more with a little bit more difficult trinomials. So we will see you next time. Bye-bye.